All right, so now we're going to use a graphing calculator and compound interest. So graphing calculator is really a useful tool for studying compound interest. We'll be using it over the next several videos on different ways to how to calculate different values. And solving that compound or continuous interest formula for the interest rate R allows us to find the rate of growth of an investment. So here we have a chart showing the growth of $10,000 of a mutual fund along with the Russell Index. And the first question to ask us is, what annual nominal rate would produce the same growth in the mutual fund if interest was compounded annually? Give the answer as a percentage rounded to 3 decimal places. So we're going to start at 10,000, go to 126,000 over a 10-year period. So with that in mind, we want to go from 10,000 to 126. So 126,000 is going to be our future value. We start with the principal added of 10,000. We're going to take 1 plus R, which we don't know, divided by 1 because we're doing it compounding annually. And then we're going to take it 1 times the number of years, and that's just 10. And so this is really what we have to solve. And so solving this, we're going to first divide everything by 10,000. Divide by 10,000. And then after that, we're going to have 120. Well, let's just get rid of 3 zeros to start with. 126 over 10 is equal to 1 plus R to the 10th. Okay. Now to solve for this, to get rid of the power 10, if we take it to the 1/10, that will help us have that out of the way. And so now we have 126 over 10 to the 1/10 is equal to 1 plus R. Solving for R, we subtract 1, subtract 1. So R is just 126 over 10 to the 1/10 minus 1. So that's what we're going to have to type into our calculator. And so let's go do that now and see what we get. And so over here, let's clear this off. So we're going to have to take the 126, oops, better put parentheses here, 126 divided by 10 raised to the power of 0.1 or 1/10. Now remember, arrow down here, or you're going to have an issue, and then minus 1. And so it looks like we have 28.836. Let's go ahead and convert that to a percentage to start with, and we know how many decimals. So it's going to be 836 is what we need for our value. And so our rate with 3 decimal places was the 28.836%. And so that was what they were asking for in that one. Now this one is another piece of it, and now it says what annual nominal rate would produce the same growth if the interest was compounded continuously. Give the answer as a percentage, again rounded to 3 decimal places. Well, guess what? We're going to work this pretty much the same way, except instead of that, we're going to have A equals PERT, RT. And so now we have to plug in our values. 126,000 equals 10,000 e to the r, which is we don't know, and time, which is going to be a 10. Now again, we divide by 10,000, divide by 10,000. And so again, if we count and cancel those 3, we'll have 126 over 10 is equal to e to the r times 10, or 10r maybe we'll write instead. Now, how do we get rid of the e in a problem? Well, we have to take the ln of both sides. So now we have the ln of 126 over 10 equals, and when we take the ln of this, that comes down in front, so we'll have 10r ln of e. Well, ln of e is just 1, and so we divide both sides by 10, and so r is just the ln of 126 over 10 divided by 10. So again, going to our calculator, we have to find ln of 126 divided by 10, and then that whole thing divided by 10, and we get this, multiply that times 100 to get our percent. So 25.337 looks to be our percent here. So the R is going to be 25.337%. Okay, so continuously compounding, we need a 25.337%. And if we have the just annual compounding, it's going to need to be 28.836. So that shows you, continuously compounding, it's compounding faster, so you need a lower interest rate here. All right, so let's stop there and then we'll come back with some more examples with calculators.